What do maple syrup, shaving cream, jello, even the ground that we stand on, mayonnaise, even our skin and our entire body, what do they all have in common? Well, if you said soft matter and they're all squishy, you're correct. Because let's just take jello or even shaving cream, for example. It acts as a liquid and a solid at the same time. Even peanut butter, even our body. Why aren't we a puddle on the ground even though we're basically water? Well, it's all the science of squishy physics. How do soft materials and soft matter act so differently, and why does this happen? Well, in this episode, I'm going to be talking to Dr. Eric Weeks. He's a professor of physics at Emory University, and he studies squishy physics, or the physics of soft matter. Let's get right into this interview so you can learn more about how jello and even our skin and even peanut butter and mayonnaise work. Trust me, it's going to be a somewhat delicious episode, except for the shaving cream and soil part. Let's get right into this interview. Let's go. Hello, Dr. Weeks.
Hi, Akshay.
How are you?
Doing well. How about you?
Really great, and I'm really excited to talk about soft matter with you. And thank you so much again for joining me today. I really appreciate it.
You're very welcome. Thanks for the invitation.
All right. So, can you please introduce yourself to the listeners?
I'm Eric Weeks. I'm a professor of physics at Emory University, and I've been at Emory for about 24 years now.
Wow, 24 years. And you've been studying soft matter?
I have, I still am, yes.
Wow, that's
Um,
amazing. And we'll get more into that science, and it's really interesting because it happens all around you. And we'll get more into that later. But first, how did you get interested in science?
when I was a kid, I was interested in lots of things. Um, I was decent at math and enjoyed my science classes, but I enjoyed other things. I guess when I was in high school, I got more and more interested in my science classes. Um, and also my math classes. And science seemed like a good way to combine both math and science into one career. But also, I kind of thought I might change my mind a few times. I wasn't really too worried about what I was going to do. I was just trying to be in the moment, enjoy what I was doing. And it turned out by the time I was really committed to science, I'd fallen in love with it and was happy to stick with it.
Wow, and especially physics, it really combines math and science, so that's perfect for
I guess
you.
also I was influenced a little bit by my father, who has had a career in engineering.
Oh, wow. So you were kind of in the middle of everything, but eventually you ended up doing physics, which is awesome.
Yeah, yeah, I like physics because it's about understanding how things work, and there's not a whole lot of memorization to it.
Yep.
I thought briefly about biology, which I also enjoyed biology, but there was clearly more memorization. I prefer less memorization.
Yep. So what do you study in your lab?
So it's called soft condensed matter, which is the physics of squishy things like sand and shaving cream and mayonnaise, um, and yeah, just squishy things in general. Um, so I don't literally study mayonnaise, sadly, but I do study emulsions, which are mixtures of like oil and water and soap. We do study sand of various kinds. Um, I don't actually study people, but people are soft materials. I can't normally do this with something that's a solid.
Yeah.
Um, you can think of it as the human body is some large percentage water, but yet we're not puddles on the ground. So that is soft matter physics is a bit of how we can have structure to ourselves, not just with bones, but also even our fleshy tissues are somewhat like solids, but also they're flexible. So it's that kind of science. It's how do these things get their properties, um, and what can we understand about them?
Yeah, what I realized, especially in my interview earlier with Mr. Mir, I was saying that soft matter sounds really delicious, like jello, mayonnaise. What else?
Uh, yeah, there is definitely a lot of relationship to food. There are a number of soft matter scientists who are in the food industry.
Oh, wow.
Um, for example, if you're going to change the recipe somehow, but maybe you want the texture to be the same, or maybe you're going to make a low fat product, and you take the fat out, and maybe some food chemist tells you put this other chemical in, or put olive oil or whatever,
Hmm.
and it will be safe and not kill you. That's the chemist's job, and the physicist's job is to say, well, that chemical has a different viscosity or a different density, so you need to make the droplets different sizes, or you need to add in some kind of thickener, or like that's the thing that the kind of question we relate to. But apart from food, it's also things like soil mechanics. Um, if you have an earthquake and the soil is shaking, how does that become a little bit like a liquid? If you have an avalanche, how does the snow tumble down and what's going on in that? What triggers it? So there's questions that can be related to geoscience. Um, some of it is also like in the oil industry. So dealing with oil and how it flows and moves around underground and how you push it out. I know some soft matter people who work in the skincare industry. And to be clear, I don't really work in any of these industries. I'm doing pure basic science. So I'm just kind of doing things that make me curious and I'm interested in. But then I talk to people in industry who can sometimes take what we learn and apply it to their specific situation.
So you're kind of in all the industries at once, basically. You study everything in a general, broad perspective.
Yeah, and with the hopes that other people will find what we do useful and interesting and applicable in something that's more specialized.
And that's the cool thing about soft matter and even granular fluids and everything. It's because it can be applied to a wide variety of fields without you having to study one specific thing. They can be used everywhere, and we'll get more into how it's used in our everyday lives and what role it plays in our lives later in the episode.
Cool.
But first, let's answer the really, really mind blowing question, which is why does soft matter act so strange? Notice like jello, mayonnaise, like you gave the examples, shaving cream, even maple syrup, but other things such as soil. Why does it act so differently?
Um, I think there's different answers depending on the material, but I thought of two good examples. So with sand, uh, you know, sand is composed of solid particles. And if you say to a physicist or an engineer, what do we understand about a solid particle? That's like really easy, straightforward. We can understand how we compress it and friction and things like that. But when you make a collection of all these particles, like you make a big pile of sand, then you start getting into like, well, then I don't completely know how it works together collectively. And a lot of that is because of friction. Sand grains slide against each other and there's friction, and that is what resists them from flowing completely. But then like it's collective action and how they interact multiply between the different grains of sand gets really, really complicated. And it's also very disorganized. So scientists understand a lot about how like metals work because metals are periodic arrangements of atoms in an array. And so the fact that it's periodic and reproducible makes it easier to understand. But sand is a disordered jumble. So how do you average over the disorder, and how does that lead to the properties? Is where it gets really interesting. And again, friction is not even completely well understood. Um, so the complexities of friction can also make sand get more complicated as well. Um, and then another one that's interesting is like let's take shaving cream. So shaving cream is made out of soapy water and air, and soapy water is a fluid,
Hmm.
and air is a gas. And these two things together make something that can make a pile of itself on a table. And that's a little bit like a solid. And in fact, you could think of it as I could have a pile of shaving cream on a table and it can support some weight, like maybe a small piece of paper. It can't support very much weight. It's not like a very sturdy solid, but it can support some weight. And that seems a lot like a solid. And that has to do with, again, like you have like individual bubbles, which we can kind of understand, but the collective action of many bubbles um, is where it gets interesting. And that has a lot to do with surface tension. So you know how surface tension wants to make things round?
Hmm.
Like that's why bubbles are round, because of surface
Yeah.
tension. You've kind of heard that before, and that's true.
Hmm.
Surface tension is an energy penalty for making things that have more surface area. So like if you squish a bubble, you're increasing the surface area compared to the volume, you're changing it a little bit. So that costs you energy, so it tries to make it circular. So if you have a pile of these bubbles in a shaving cream foam, then if you try to compress it, you're making all those droplets a little bit, all those bubbles a little bit not spherical anymore.
Hmm.
And that resists it from surface tension. So it's the kind of collective action of surface tension that makes a shaving cream foam a bit like a solid material. And
Wow.
again, like you can still, there's an energy penalty, but maybe not a very big one. So you can still, squish the foam and make it flow and
Hmm.
really distort it. But that being said, like it's that kind of weirdness of surface tension that changes from just a single bubble wants to be round to like a shaving cream foam wants to be a pile.
Wow, and in fact, I was eating waffles this morning. I realized that maple syrup, it's also somewhat a soft fluid, right? Because when you put it in, let's say the fridge, it starts getting solidified, and it's hard. It takes more energy to pour it onto your waffles. But then when you don't keep it in the fridge, or when you just get it from the store, it just flows out like a liquid. So it's really
Absolutely,
cool.
yeah.
Yeah, and
Yeah,
especially shaving cream is also a really, really good example of that.
yeah, like you said, there's a lot of common examples around the house.
Yeah, and it's really cool. It can get a little messy though. Very
It
messy.
definitely can, yeah. That's what makes it fun to do science with, though.
Yeah, it's just get messy all over a lab and you just it's for science, it's for science. No, it's not. It's not my fault. It's not my fault. It's science. Anything for science.
That's right.
So, why is it important to study soft matter and how it behaves and what's the importance of it?
I think there's different ways to answer the questions. From like just a science point of view, I think it's just a frontier of science. And we're used to hearing about frontiers of physics being like black holes and quantum mechanics and string theory. And those are frontiers of science. But also frontiers are just like we don't really understand these collective properties of things like sand and foams and gels and pastes. And to me, it's interesting to think that these are, fairly common objects, common materials, and yet we're still learning their secrets.
Mhm.
Um, it's also a bit of like, what kind of strategies can you employ as a scientist to understand these things that are composed of disordered, collections of material? Like sand and shaving cream are both disorganized. So are there strategies you can use to study both of them? And the answer is yes, there are strategies that people use to study both of these kinds of systems. So looking for just new kinds of physics strategies is a fun frontier of science as like a broad picture. Um, but then, more practically speaking, a lot of it does get back to industry. If you want to process these materials, if you want to manipulate them in a factory, what do you need to think about them? Um, if you were trying to change the material some way, like I was giving an example of low-fat food products, then how do you change that material? One example I once got from somebody, a scientist who worked at Pillsbury, was how you can buy like bread dough in a can?
Oh yeah.
And when you cook your bread dough in a can, you expect the bread to come out the same way every single time.
Mhm.
And every year, the wheat crop is a little bit different. Some years are hotter, some years are drier, some years are wetter. So every year, the wheat is a little bit different. So every year, Pillsbury has to change their recipe, I was told,
Oh wow.
um, to make sure that the consumer experience is always the same. And then the question can be like, as a scientist, how can we quantify what the consumer is experiencing? So like, what is it about the bread that is the soft properties of bread and how it feels in your mouth? Like, how do you
Mhm.
attach numbers to that? So I thought that was a really interesting application
That is
of
really interesting.
just like, what kind of properties can we measure? How do we describe what people are sensing when they're experiencing food or skincare lotion when you're spreading on your hand? Like, how does that feel to you? So there's just interesting industry applications there.
Yeah, it's a lot of things overlapping together from it's also consumer psychology. It's so many different things
There's
because
chemistry
it's chemistry,
involved. Yeah,
physics. Wow, that's it's just all this science packed into a can of shaving cream or even a can of bread. That is that is really really amazing. It's also the
yeah,
recipes, how it tastes. All those tiny little variables could impact how the entire thing ends up, right? Because you said different wheat crop, different amounts of water, everything could just completely
yeah.
throw off
Food
the
science,
recipe.
agriculture. Yeah, I love that in general, as a scientist, one can look at these problems that are a little bit multidisciplinary. And I
Hmm.
love that, especially in industry, there can be these multidisciplinary teams of people who are working on solving various problems and bring in their expertises. I mean,
Yep,
we
it's
tend to
so
break
true.
things into disciplines. You take a physics class, you take a chemistry class, but then the real world doesn't necessarily stay within those boundaries. And, as a scientist, that's fine. You go where the science is.
Yep. You go where the science is. That's a really, really good that's a really good saying. You go where the science is. And where the science is taking us is into the real life applications of soft matter. So I know you touched on this previously, but what are some more of the real life applications that soft matter has?
I'm trying to think of new examples that we haven't already gone through. Uh, Food is usually my go-to example, but Paint. Paint is one. You can think of it as like you need the paint in the can to still to be a liquid. That's
Mhm.
important for applying the paint to the wall. The paint is composed of like a liquid and then a bunch of solid particles, which are the pigments. And then when you paint on the wall, you need the liquid to evaporate, and then the paint needs to stick to the wall. The sticking to the wall is pretty darn important there.
Yep.
But you need it to not stick to itself in the jar. Like if the part, so the particles need to be sticky, but not to themselves, but instead to walls. So there's a fair bit of soft matter science and how do you engineer things like paint. And then ink, and then you can think about ink and inkjet printers.
Mhm.
Um, so that's one application. Um, there's a whole realm of physics I don't know a ton about, but which is related to the soft matter properties of biological materials. So we started the conversation talking about how people are soft materials.
Mhm.
Um, so there's definitely studies of that. And one thing I remember hearing about one time was that cancer cells are often squishier. They're softer than
Yep.
regular tissues. So then people were trying to figure out if there was ways to use the physical properties of the differences in cells to identify which ones are cancerous and which ones aren't.
Mhm.
Um,
Wow.
so yeah, it's I mean, one way we put it when we have people touring a lab is that everyone's heard of solids, liquids, and gases.
Mhm.
And there's a lot of soft materials that are kind of in between these states, and they're not uncommon. You don't have to go to a lab to find a jar of peanut butter, or as you say, like a bowl of Jello, and to realize that this is something that's a little bit different.
Yeah, and it's just all around us, even the ground that we walk on is
Even the ground we
example
walk
of
on.
the ground we trust with our lives.
Yep, which
It's
properties change a fair bit when it's been raining hard.
yep, a lot, and especially lately it's been so hot, so the ground starts solidifying, and it's hard to dig a hole to plant something because of
Yep,
the water not being in the soil itself.
yep, yep.
It's so interesting. It's just all around us. You don't have to go looking for a black hole in your backyard.
That's right.
You can just look at the soil in your backyard or even the jello on your plate and you'll be like, "Whoa, that's physics." All right.
Yep.
So, what advice do you have for kids who are interested in science?
Yeah, you sent me this question in advance, and I want to be honest. I don't think I have a lot of really strong advice on this. I think stay curious, uh, and don't stress. Don't stress about it. You know, if you're enjoying science, there's tons of things on the internet. There are podcasts you can listen to, obviously, like this one. There's YouTube videos, but at the same time, you know, do what you enjoy and don't stress about it. Um, I tried to do two science fair projects when I was a kid, and both of them I kind of abandoned very early on. And I don't think there was any harm done. Like I wasn't enjoying it, and it wasn't like I needed to do them to have a career in science. I just was enjoying my classes and doing what seemed interesting to me. So I don't think I have a lot of advice of like, especially I wouldn't want to be like, and if you don't follow this advice, you're doomed and you'll never
Yeah.
get to do science. Like just you know, do what's fun, and if it's science right now, then that's great. And if your curiosity takes you someplace else, that's probably fine too.
Yeah, it's curiosity takes you places, and I can see especially with you, it took you to Jello, to shaving cream, to peanut butter, everything all around us.
Exactly, and that certainly wasn't where I started my career in science either. So you know, when I went away to college to do physics, I didn't think to myself, oh, and I can't wait to study squishy things. Like that wasn't anywhere on my brain. But I knew I was enjoying what I was learning, and that was, you know, what I just kept putting one foot in front of the other, and this is where I ended up.
I mean, it technically was in your brain. Isn't your brain also a squishy thing?
That is true. That is true.
Yeah, it was technically in your brain somewhere.
It
Yeah,
was.
that is great. Thank you so much again for joining me today. I really enjoyed it. I learned so much about soft matter and squishy things in general and all your advice, which is really important. Listen to the squishy thing in your head. That's what you need.
Well,
That's what you
it's been
need.
great to talk with you. I've enjoyed the
Yes, thank you so
conversation.
much. Thank you for joining me. Thank you so much for listening to this episode of Spectacular Science. Spectacular Science is produced and hosted by me, Ashish Raman, and our theme song and additional music are by Chan Ramachandran. Special thanks to Dr. Eric Weeks for accepting my interview invite. Dr. Weeks, I learned so much, and it is just amazing to see all the soft matter and squishy physics all around us. It is some really, really interesting science. Thank you so much. Please visit my podcast website, spectacularsci.com, to find interactive activities, articles, and blog posts. That's spectacularsci.com. Do you have a science question you want answered on a Spectacular Science episode and you get a special shout out? Well, grab an adult and head over to spectacularsci.com/contact. There you can find a contact form where you can send me your amazing science questions. Thank you so much. Also, don't forget to subscribe to this podcast if you're listening right now. It really encourages me, and you'll be updated on all the new episodes. Subscribe and share this podcast with your friends and family. Thank you so much. Thanks for listening, and we'll see you on the next episode of Spectacular Science next week. Keep thinking about science. Cornstarch and water make a really interesting combination, but the only problem is it's really hard to clean up. Oh, it's everywhere. I guess I gotta spray it down with the hose. This will probably take me a while.